So welcome to all the attendees and thank you for joining us today. We are happy to share a process improvement journey to achieve software excellence through our agile high velocity development process. So here we would like to set context of who we are, just one second. We want to share who we are so that it helps to better understand why we do what we do. Then we will dig deeper into the agile high velocity development, then just touch base on the quantitative techniques in high velocity development. And then we will share results and customer benefits, few of them, and then conclude with our key insights. So first we are ISHPI Information Technologies, DBA ISHPI. We are US federal government contractors. We perform IT, cybersecurity, engineering, software development, modernization, maintenance, and sustainment services to the Department of Defense, Department of Homeland Security, and other federal agencies. So ISHPI AIS Division. The AIS Division is one of the divisions under ISHPI. So it consists of projects over which we have management control over the execution of the project and its processes. So our objective of ISHPI AIS Division and also overall ISHPI is to continuously advance the boundaries of quality and security so that our customers have a positive experience with us. So quality and security are the drivers for our results because we realize that defective software is inherently insecure, and bottom line is quality work minimizes effort, schedule is more predictable, and it minimizes total cost to our customers. So we would like to share few seconds to address Watts Humphrey's influence on us, and this is the perfect forum for that. As we all know, Watts Humphrey is known as the father of software quality. He has been a great inspiration and guiding light to all of us. I remember his visits to Peoria, Illinois office, which is no easy task because you have to get down at the Chicago airport and then you have to drive 3 miles to come to Peoria. It is like right in the Midwest. But his visits used to generate so much energy and enthusiasm. I remember our project managers running around, printing data, meeting with him, discussing improvement opportunities, and he would suggest action items, and he would also remember to follow up on previous action items. In short, he was our guru. Therefore, this presentation is our homage to him in a way. So we are really grateful for the opportunity. So digging into what is high velocity development. So the HVD is comprised of several standards, processes, and frameworks, basically that emphasize quality and excellence. So we start off by the personal software process at the individual level. So we use it to estimate, plan, and make commitments. We plan and manage quality, and we also use the feedback loop to continuously improve. And the most important thing is all these are based on data. So as we move forward through the presentation, you will see aspects of these coming through. And then at a higher level, we have the team software process at the team level. It is a similar concept, but same as PSP, but at the team level, we leverage the personal data to the team level. The launch is the hallmark of TSP for us. And then we have the two CMMIs, CMMI for development, and then we have CMMI for services. So the above are what we have chosen to achieve excellence in software. But we cannot operate in a silo. AIS Division cannot operate at its maximum efficiency in a vacuum, right? It is well supported by the following at the ISHPI corporate level. For example, ISO 9001, then we have ISO 20000-1, which is very similar to CMMI for services, except that it's a standard versus a framework. Then we have ISO 20001 for the information security system. And then we have the cybersecurity maturity model certification, self-certified at level 2. So all these certifications and appraisals have led to a culture of continuous improvement throughout ISHPI. Anyone who has gone through the audits and the appraisals can relate that these are great, huge opportunities to learn best practices. But I'm sure each one of you may have a question that are all these necessary? Do we need to have all these certifications or standards to achieve software excellence? So not necessarily, but do you need all these certifications? For that, my answer would be, it depends on your business objectives. What are your goals for your company? For our business to be competitive in the federal world, we do need this ISO certifications. But what we have done here is we have made sure that all these processes complement each other. For example, when we are ready to take on a new certification, we conduct gap analysis and leverage processes that are already existing rather than create a whole bunch of new processes. For example, ISO 9001 has risk and opportunity management processes that can be leveraged throughout the CMMI framework, for example, for development services and the ISO certifications also. So bottom line is, for our practitioners, engineers, project managers, it is a seamless blend of processes, which we call the high velocity development. So to add a little bit more, to the high velocity development, in the last 6 appraisals, the high velocity development processes have been repeatedly appraised at maturity level 5. What does level 5 indicate? It indicates that the organization is performing at an optimizing level, and optimizing means that organization is continually improving its processes, and again based on a quantitative understanding of its business objectives and performance. And since we are driven by, and since we undergo these appraisals and audits periodically, we are driven by our appraisers and auditors to be to continuously be lean and agile, but without sacrificing the discipline or the best practices of CMMI. And also our contracts can be so different. Every time we win a new contract, it's in a different environment. So it is very important for us to keep our practices highly tailorable and tools and technology agnostic. And then all through, you will see that all these practices have a relentless focus on quality to produce secure software. So what do we, to expand further, we say that high velocity development is more than a method, is more than a methodology. That is because high velocity development consists of all this ISHPI process asset library, which contains policies, standards, templates, even statistical techniques, tools and utilities. Then we make use of our capability data, historical data, and you will see that a little bit further down. And then there is a relentless focus on our engineers getting the most recent security certifications, and we also encourage our engineers to update their checklist based on OWASP and CWE vulnerabilities that are produced, top 25, top 10. And then there is that underlying culture that I mentioned of continual improvement. And then we have this repository of training for requirements engineering, inspections, and high velocity development itself. And then there is this software center of excellence support to help our project teams excel. That is the QA over quality assurance oversight, configuration management oversight, coaching and mentoring, and required training for the teams. And throughout, there is this management oversight and support wherever the team requires that. And we'll see that in a little bit more detail towards the end. And then we have the tools and technologies. For example, our ALM tools, some projects use Jira, some use Azure DevOps, some use Redmines. So that's why we say that high velocity development is more than a methodology. So as I mentioned, that team software process, the project launch is the highlight or the hallmark for us. So during this is launched, the process happens during the planning stage. Typically the launch happens about quarterly depending on the project, and typically for multiple increments at a time. And this is led by a team coach to be most effective. And the entire team participates in the launch. So what are the deliverables from this launch? This is, you take the business needs, the customer needs, manage ISHPI management goals, and what are the product requirements, and you come out of that one meeting which says what are the team goals based on the customer and ISHPI management, and what are the deliverables that are expected of them, and a high level or conceptual design. Once you know what needs to be done, then the team decides during a meeting, which is like how will you do it? What is the development strategy? And you can tailor your process based on the development strategy and all this needs that you have that you know at the beginning. And then you come out with a task plan and a schedule plan based on the size and effort estimates. And these estimates are based on the historical data of the engineers and the team. And we also have org data. If the team doesn't have their own data, they can draw it from the organization. Then who will do what? Here we do the resource assignment based on their availability and load balancing. And then they decide on team roles such as quality manager, configuration manager, and so on. And how well? It can be as simple as we are going to deliver first time right 99% of the time. That's the quality plan. And what if is we do risk and opportunity management meetings, and we create a risk and mitigation plan, and if needed come back and adjust the plan. And then if that plan doesn't satisfy the customer needs, we go ahead and create alternate plans until we come to a commitment with the customer. So as I mentioned, that during the launch is when we tailor our processes. So based on the customer needs and customer inputs or constraints. For example, you have to be off the mainframe within a month kind of constraints. Or project attributes. Project attributes can be criticality. For example, it could be a healthcare device, which is highly critical versus proof of concept project. And using the launch process and ISHPI management guidance and an experienced coach, you tailor elements of the process. For example, I can say for some development environments, you don't need integration testing. So this is where you tailor that. And that is a selection of elements. That is one level of tailoring. And within the selected elements, there is another level of training. For example, peer review. What kind of peer review you want to conduct for your team? Again, based on the criticality of your project. So based on that, a plan is formed. And this tailored process, it is not ad hoc, because that is reviewed by the quality assurance representative just to make sure that the underlying aspects of quality and security are not sidelined because you have to deliver in a hurry to the customer. So that is reviewed by the QA representative before it is shown to the customer. So this is the execution or the implementation. Most of these things are same. What I want to highlight is after the team goes through the launch process, there is something different about this team. It is a disciplined, self-managed team. Why why we say it is a disciplined, self-managed team is because after going through the launch process, now the team members own the process. They own the development strategy because they selected it themselves. And then they made the commitment to the customer based on their historical data. So basically, it is their plan, not just the project managers or program managers' plan. It is their plan. So they have that conviction to defend their plan. So one of the key elements to arrive at this disciplined self-managed team is also the part of a software center of excellence coaching support. The team coach is very critical here, not only during the launch process, but also to provide mentoring for the team members to maximize the benefits of the data available at the individual level, at the team level, and also at the org level. And then also continuous improvement, as we will see later, one of the key differentiators here is the retrospectives and causal analysis are totally driven by data. So that helps the team to make a decision with great clarity. So one of the things that comes out of that launch is performance metrics or team goals, as we call them. So this is one example of one of our teams. So the first one is on-time releases. We typically have one schedule, one quality, one effort kind of performance metrics. So first one is on-time release. What is the measure? It is the ratio of the number of releases delivered to user acceptance test on or ahead of schedule compared to the total releases. So here the target is that they want to be 100% ahead or on schedule. And as of 5:31, when I took this screenshot, they were 100% on target. So these performance metrics are reviewed periodically, typically once in 2 weeks. This is to ensure that the performance standards and customer specified acceptable quality levels will ultimately be met rather than be surprised at the end of the project or at the end of the contract. So as I mentioned, this high velocity teams are supported by the software center of excellence. I lead the center of excellence. I bring in additional team members as the need arises. And this COIS provides QA and CM guidance, coaching, make sure that we are compliant with the contractual requirements, and also it provides software engineering process group leadership. So here something that I feel we do very well in ISHPI is that our QA and CM goals are very aligned with the project goals. So our goal is not to find the maximum deviations or non-compliances. Our goal is to find zero when we do this audits. So it is highly imperative that we are collaborative with the project managers to iron out issues early in the game rather than at the time of delivery. We are just another support for the project managers to achieve their goals. And the software engineering process group, it is at org level. They analyze performance with respect to business objectives, and then we leverage lessons learned across the organization, evaluate new methods and technologies, and pilot and implement, and then basically we maintain a consistent and persistent environment of continuous improvement across the projects. So here we have these projects like a factory, each a small project versus a big project, all of them executing, and they are delivering outputs here. But one of the things most valuable to us, of course, these are valuable to the customer, and most importantly is we come to know what is their capability, what is their performance capability, and also they are spitting out project data. And we are gathering from them innovations, lessons learned, process improvements, and all that is going back to the high velocity development toolbox. So some of the things that come out, they come out as process improvement proposals, which we call as PIPs. And mostly the vehicle to recognize or identify those are retrospective and causal analysis. So those are evaluated, received and evaluated by the Software Engineering Process Group, SCPG, and they typically prioritize the one that focus on customer value, where we improve quality, reduce risk, reduce schedule, and all that. And since the process improvement proposals are identified by the practitioners themselves, and there is the seamless integration. Therefore, the changes that are incorporated are seamlessly, changes identified as seamlessly incorporated and easily institutionalized. Next, Steve will present some of the key differentiators of high velocity development.
Thank you, Bharti. As Bharti mentioned, I would like to highlight some of the key differences between traditional Agile implementations, such as Scrum, and how we've implemented Agile practices in high velocity development. Of course, there's many similarities between the two, and we leverage a lot of concepts from traditional Agile techniques, such as Scrum, and we don't have time to go into every aspect in depth, but I'd like to highlight just a few key differences. So for example, in terms of frequency of delivery. So within Agile Scrum, we typically have time box sprints of approximately 2 to 4 weeks. Within Agile high velocity development, we're also highly iterative, but not necessarily time boxed. And instead, the durations and the cycles are driven by the team strategy. And with high velocity development, there's no problem planning multiple iterations to make longer term commitments, which our customers still often demand. And so the benefit there is we have flexibility to formulate the most efficient development approach to meet customers' needs. Another element that I can highlight, for example, is empowering individuals. So with traditional Agile Scrum techniques, the concept there is to support motivated individuals, typically through a Scrum Master. With Agile high velocity development, we emphasize training and mentoring beyond just the engineering role, and also developing other skills, supporting skills like estimation and quality management. And we do that through a significant emphasis on coaching. On this slide, I can highlight the measuring process. With traditional Agile Scrum techniques, the principle there is to focus on working software. With Agile high velocity development, we really focus on using our data to ensure that we're on track to delivering all the required work products on schedule. Similarly, keeping a project pace. With mainstream Agile Scrum, the principle there is to maintain a constant pace. Again, as I mentioned on the previous slide, typically 2 to 4 week sprints. So with high velocity development, we focus on using our data to ensure that we're delivering all the work products, and then again, still highly iterative, but make sure that we're focusing on our data to maintaining that steady earned value progress, equivalent to burn down, for example, that follows our plan, and all that's driven by empirical data. That empirical data demonstrates that the team's capability and productivity can actually sustain that plan. So the team can do a launch to plan detailed iterations, and then they can also make higher level commitments for longer term releases. So the benefits of all of that are on-time delivery of working software without accumulating lots of technical debt, and also that the teams are able to meet aggressive but realistic commitments. And then on slide 17, Simplicity, for example. Within traditional Agile Scrum techniques, the notion is to maximize the amount of work not done. Within Agile High Velocity Development, we focus on all the tasks and work products that add value and executing them as efficiently as possible, especially by making sure that we're completing them right the first time and preventing all of the rework that would be inefficient. So the benefit there is that this results in cost savings for us and for our customers, making us competitive. And then the element of improvement. Again, with traditional Agile Scrum, the principle is on periodic reflection and adjustment through retrospectives. With Agile High Velocity Development, we also perform increment retrospectives. But in addition to that, above and beyond that, individual team members also perform personal retrospectives at the end of each developed component. And we focus on continuous improvement at the organization level as well. And one of the main differences with high velocity development is that we, as Barty mentioned a short time ago, we really focus on the data to objectively understand how we did and to give us insight into where we should focus on improving in the future. So the benefit that we really see is using our proven practices that have been fine-tuned over a long period of time, and in our case, even over decades. So by now you can tell that there are some overarching aspects to high velocity development, both based on what Barty has already explained and by what I'm highlighting. And one of those overarching aspects is being data-driven. In all aspects of our process, we really focus on leveraging data to give us a great deal of visibility into the status of our activities, give us an objective understanding of our performance and what our capability is so that we can make responsible commitments. And we do all of this in part through the use of statistics, which I'll be discussing more about in just a moment. And the notion there, or the benefit, is that teams are consistently able to meet commitments, which is really a delight to our customers. And then the other overarching aspect is building in quality. We really focus on integrating quality steps throughout our process to remove defects as early as possible in the process when they have the least cost impact, or even better, to even prevent them from occurring altogether. And how do we do this? Well, we do this through incorporation of walkthroughs and personal reviews and peer reviews and multiple levels of testing, and through quantitative monitoring quality by instrumenting our whole life cycle, not just the later test phases in the life cycle. And so the benefit that we see is that we have secure working software that's right the first time, which incidentally thrills our customers, and that lowers our overall cost. So next, I'd like to talk about some of those quantitative techniques that we apply throughout high velocity development. So as the image on the right shows, we collect data at the individual level, at the project team level, and at the organization level. Each individual team member collects data through the performance of their normal daily work. And then every week, individuals make data available to the project team. Individuals and team members analyze that data periodically, for example, during their team status meetings and during their retrospectives. And at some specific milestones, such as retrospectives, project teams submit that data to the Software Engineering Process Group, the SEPG, to include it in the organization's repository. When individuals and teams need to make commitments for future work, they're able to draw upon their own historical data, or sometimes, as Barty mentioned, higher level, organizational level data to make more accurate estimates and plans. And all of this boils down to the four fundamental measures that permeate our process: size, effort, schedule, and defects. Now, we apply statistical techniques at all levels, but most importantly, we apply them by individual team members and by the project team. Now, the SCPG does provide guidance and support. As Barty mentioned, through the Software Center of Excellence, they analyze data across projects to understand our overall organizational capability, and they apply statistical techniques that provide us a deep understanding of our overall capabilities. And the focus there is always on business value. Now, these statistical techniques alone are a large topic, and I did a presentation to the Software Excellence Alliance back in February of 2023. So you can reference that presentation. So in here, I'll just give a quick summary of the techniques. So first, we apply an object or component size database and also histograms. We use our object or component size database to understand the actual sizes of work that we've performed in the past in order to estimate future planned components. And we use that data to make estimates based on relative sizes, and that helps us to do that more accurately by being empirical. We calculate those t-shirt sizes. So for a given chunk of work, for example, a component, we can estimate whether that's large or small or medium or very large. And so those t-shirt sizes are derived empirically. And then we use histograms to understand and visualize the distribution of data sets and understand their similarities and differences. And we can do that for just about any data we might be interested in analyzing. Next, we apply linear regression. We extend linear regression to prediction intervals, and we apply process performance models. So we use linear regression to understand the correlation between two data sets. And that could be again, on any data set that we might be interested in analyzing to come into a deeper understanding. We then apply prediction intervals, especially to adjust raw estimates that we might make to correct for estimation bias and to analyze the range of expected results around those adjusted estimates. So the idea there is that we have a raw estimate, we apply linear regression to adjust those raw estimates to correct for bias, and then we understand around that that sort of average estimate what the range of expected results might be within, for example, a 70% prediction interval. So it would give us an upper prediction interval, a UPI, and then it would also give us a lower prediction interval, an LPI. And all of that helps us to understand for a given commitment, what degree of risk are we taking on for ourselves as a team or perhaps as an organization, and we can adjust those control parameters. For example, we can choose to narrow or widen the prediction interval. And we can apply these practices to project increment commitments for individual development cycles, or when estimating sometimes whole entire projects, so making higher level commitments. We also apply, as another statistical technique, control charts. We use control charts to monitor performance of not all of our practices, but of our most important processes. And the idea there is to ensure that they're behaving naturally or predictably. We also use them to understand that process's capability. So not only the average performance, but also the variation around that mean. And we also use it to understand how that process performance has evolved over time. We monitor control charts to understand whether there have been failed tests that would indicate to us that there's a signal that needs to be investigated. So those signals might indicate something that might be a negative thing, that something might have gone wrong, or they might indicate a positive, better than normal performance, or they may not have any impact at all, but just that there's a signal that we need to dig deeper down into to understand what's really happening there, and then understand whether we need to take corrective action or not in order to stay on our plan. So some examples of where we apply control charts, especially at the component estimation level, by monitoring component estimation error. And we also instrument our peer review process to make sure our preparation rate and our defect density for defects found during peer reviews is within the range that we would expect. Now, as an organization, we periodically analyze the organization level data to understand our overall capability. And the SCPG is the organization that does that analysis prior to each project and process status review, or PPSR we call them. And so we do this analysis to guide decisions and actions to make sure that we're meeting ISHPI business objectives, again, at the organizational level. To analyze assignable causes and common causes of process behavior so that we make sure that we're addressing those, and to implement targeted process improvements. And the SCPG publishes process capability baselines and updated organization goals on a periodic basis, and makes those available to the larger organization. Next, Barty is going to discuss our results and some of the customer benefits we've experienced through our use of high velocity development.
So how does a CMMI level 5 rating benefit our customer? Because that's the end goal for us. So as we see in the graph, the risk to throwing scope overboard, or risk to overflowing the budget, or risk to not meeting the schedule or delivering quality, as we delivering a bad quality product, increases or in the lower levels, or rather decreases as the maturity level of the organization increases. And we can also see that this line, the cost to customer is an investment in process, also reaches the peak towards level 2, and then it decreases as it reaches level 5. So this is, the cost is low due to the low maintenance cost of the solution or the product. That is because there is practically no rework. We will show that how we deliver first time right, majority of the time, which leads to absolutely minimal rework. So this reduced cost in maintenance enables our customers to use their budget towards enhancements or adding new features versus just using it for maintenance purposes. So another thing is we also have ISHPI process asset library on a SharePoint that I showed earlier, and that enables a rapid startup for a customer. That also leads to shorter schedule and therefore lower total cost to the customer. So these are some of the results, couple of graphs that I want to show that that shows our results. So this graph is for schedule improvements. So this graph shows our schedule improvements over a period of time as we adopted capability maturity model. Here you can see that we were over 100% over time. Then we adopted PSP, then TSP, then high velocity development. So now we are at negative 2.8% schedule deviation. So this, you might be thinking that yes, we can deliver on schedule, but what about the scope? How much are you delivering? But all this we are delivering ahead of schedule with 100% of committed scope. So every release that we deliver, we not only track how late or how early we deliver, but what was your committed scope and what scope are you delivering. So all this is ahead of schedule with at least 100% committed scope. So since 2005, we have our average schedule deviation is negative 2.8%. So here I would like to highlight about the significant improvement, and that it's measured from 1988 and we have sustained it from 2005. So another result we would like to share is acceptance test defect density. This is acceptance test defects found in 1,000 lines of code. So for ISHPI's average from 2013 is 0.15 defects per K-log. And you see all these points on the line that shows that these releases were delivered with zero acceptance test defects. So what the industry average as published is 1 and above. So this is an amazing result for us. So bottom line, what it does is it leads to some predictable schedule, because we can plan that we have so few defects or zero defects. So that leads us to predict a schedule better. And most importantly, since the customer doesn't have to perform acceptance tests multiple times, it is significant cost savings for them. So another way we measure is first time right. So first time right is number of changes we deliver to the customer with no acceptance test defects, be it a JIRA or a Redmine or work item or support request. So green is the one total number of support requests we delivered, and the dotted line is we delivered them first time right. First time right is we delivered to the customer that change support request and there were no acceptance test defects in that requirement or that support request. So as you can see, most of the times the green and dotted lines are following each other. Once in a while, we have one where we have to rework and deliver. The red line is the one that we had to resolve with some rework. But as you can see, most of the times it is at zero. Once in a while, we have to deliver one. With some rework. So we have delivered 95% of our support requests first time right from 2016. So again, I would like to highlight that this is a significant result. We have been continuously measuring it from 2016, and the results, as you can see, we have sustained. I think for a long time we have been over 90%, as far as I remember, maybe from 2018 or so. So again, what it leads to is leads to a predictable schedule for us. And also again, since most of our changes do not require repeated deliveries, our customers don't have to do repeat acceptance test defects, leading to significant cost savings for them. So all these results have led to happy customers, I would say, and we typically collect customer feedback at the end of a contract or at the end of major milestones. And as if you pay attention to this violet line from 2013 to 2022, 97.1% of our customers have said that that we exceeded their needs, not even met. We exceeded their needs and expectations. And it starts at 2022 because this is the beginning of a project rather than the end. So some of the results for 2023 would be coming in. So this is incredible. This is for quality, value, and timeliness. So some of our management practices to produce these results. One is we staff the project with team members who are trained in estimating, planning, tracking, measuring, and managing quality. So here, earlier we used to take 2 weeks upfront to train whoever we add to the AIS division, but the customers change and customer wants them to be productive the first day. So what we have realized is coaching and mentoring is again a big thing. And also just in time and over the job training is what we have kind of strategically replaced the earlier training. And then it is really helpful to start the project with a cohesive team. That means that having the entire team participate in a launch really helps them to have a common vision. They are not operating in silos, so that really helps. And again, here a coach is very important here. And the next two is the support that the center of excellence, the project managers, the coaches, they all, we are a small division, so it's not necessary that each of this role is done by a whole different person. Sometimes the coach and the manager may be the same person. It's not necessary that it has to be a different person. But the one thing that is absolutely necessary is the mentoring and coaching, which has to be consistent and it has to be periodic, because that helps the teams in collecting quality data, and it helps to analyze, and it helps to report, and the coaches help the teams come to important decisions using that data. And it's very important to explain to the team members why we are collecting this data, so that there is less resistance. Otherwise, if they just collect data and they don't know how they're using, we kind of tend to lose them. So that's where it is so important that we have that periodic coaching, to explain to them, hey, you are collecting this data, this is how we are using, see, this is how it is helping us to come to a decision. And the next two items seem like a little bit low level, but as Steve mentioned, peer review is very important process to us. So we want to make sure that we do it effectively, because that is our gateway to catch, gateway to release a product with the fewest number of defects or zero defects. And then we also ensure that quality is built in throughout the project, starting from requirements. That is another thing we pay attention to.
So I'd like to go ahead and finish up our presentation today just by sharing some key perspectives from doing this software work that we've been doing over the last 30 plus years. We began our software process and improvement journey back in 1992, and it continues to this day. And the important thing for us is we know that it doesn't end. And over those years, we've benefited from top-down leadership, starting with AIS's founder, Girish Seshagiri, and continuing to the current ISHPI management team, and also bottom-up involvement in defining and refining and streamlining our practices. Now, overall this time, we've maintained a persistent focus on quality and security as drivers for performance improvements, being more predictable and efficient, and using that data to really understand our capabilities and process improvement as an ongoing and never-ending activity. So that seemingly simple plan, do, check, act improvement cycle, it's a really powerful tool that can have extraordinary impact over time. I really hope that we've inspired you by showing you that even a relatively small organization that's dedicated to excellence can achieve what we believe are really extraordinary results. And we really believe that the key to this has been to make sure that all of these efforts are in support of our business objectives and priorities, that alignment. I hope we've conveyed that the steps in our process, they're not extra. They're integrated into the way we do our day-to-day work, and they're an investment that pays dividends. They actually save us time by reducing risk and ensuring security and ultimately pushing down costs. One thing that has been highlighted for us in recent years is that our organization, the AIS Division, the individuals, teams in our software organization, they're part of an even larger ecosystem, the ISHPI enterprise. And so each of those levels influence each other and they interact. And so we've learned that the capabilities of that higher level ISHPI enterprise enable the best in the AIS division and its project. And that's why part of what's motivated some of these broader process improvement initiatives, such as obtaining multiple ISO certifications and focusing not only on CMMI for development, but also CMMI for services. So these have turned out to be complementary frameworks that have benefited across the enterprise. I think our implementation of Agile high velocity development shows that organizations can incorporate ideas from a wide variety of frameworks and blend them together, and that those diverse inputs can be complementary to one another. Barty talked from a personal perspective about Watts Humphrey. One thing that has really struck me over the years is that Watts Humphrey himself was really a master at drawing upon so many ideas from diverse sources such as manufacturing and psychology and business, and he blended them together that was something more. And I think that we've done something similar to that in our own small way. And finally, Watts Humphrey himself showed us that we always need to keep learning, and we need to keep sharing and adapting. And most important of all, we need to keep improving. In closing, I'd like to thank the SEA for inviting us to share our experiences with you today. To Watts Humphrey, who is such a powerful example to us, and the SEI's TSB team, from whom we've learned so much over the years. I'd like to thank our ISHPI management team led by Earl Bowers and our corporate team for their ongoing support. And of course, Girish Seshagiri, the founder of AIS, what's now the AIS Division, and all members of ISHPI's AIS Division, both past and present, whose projects and data and results have really enabled us to present to you today.